In August of 2012, a small spacecraft, more than 120 times farther from the Sun than the Earth, crossed an invisible line, and the world celebrated. The headlines were everywhere. Voyager 1, the little probe launched in 1977, had finally left the solar system. It was the first human-made object to enter interstellar space, the void between the stars. After 35 years and billions of miles, humanity had reached the edge of its own cosmic neighbourhood and stepped beyond it. Except it had not really. What Voyager crossed in 2012 was real, and it was a genuine milestone. But the phrase, "left the solar system," was, at best, a beautiful misunderstanding. Because the true edge of the solar system, the actual gravitational boundary of our star, was not behind Voyager, it was still ahead of it, thousands of times farther ahead. So far ahead that Voyager, racing along at 38,000 miles an hour, will not reach the beginning of it for another 300 years, and will not pass through to the far side for nearly 30,000. By the time it does, the spacecraft will be a cold and silent piece of metal, long dead, drifting through a structure that almost nobody outside of astronomy has ever stopped to think about. That structure has a name. It is called the Oort Cloud, and it is the largest, emptiest, strangest, and most important part of our solar system that you have never seen. Because no one has ever seen it, not once, not with any telescope ever built. Something strange starts to happen as you approach the edge of the solar system. Let us begin. Start with the mental picture most of us carry, the one from the diagrams in school. The Sun in the middle, the planets arranged around it in neat rings, Mercury closest, then Venus, Earth, Mars, out past the giants to Neptune, with little Pluto loitering at the edge. It is a tidy image. It is also almost entirely wrong. Not because anything in it is false, but because of everything it leaves out. If you drew that diagram to scale on a sheet of paper, with the Sun at the centre and Pluto at the very edge of the page, you would have drawn about 1% of the actual solar system. The planets, all of them, every world you have ever seen photographed, are not the main feature of our home. They are the tiny, crowded dot at the centre of something almost unimaginably larger. To feel how much larger, you have to talk about distance in a different unit. Astronomers measure these spans in astronomical units. One astronomical unit is simply the distance from the Earth to the Sun, about 93 million miles. On that scale, the planets are close together. Neptune, the outermost planet, orbits at about 30 astronomical units. That is the edge of the familiar neighbourhood. The Oort Cloud is in another category of distance entirely. Its inner edge does not even begin until somewhere around 1 to 2,000 astronomical units from the Sun, and it stretches outward from there to somewhere between 50,000 and 100,000 astronomical units, perhaps farther. At its outer edge, you are nearly halfway to Proxima Centauri, the next star over. The planets sit 30 units out. The shell around them reaches 100,000. Here is one way to hold those numbers in your head. Shrink the whole system down until the Earth sits exactly 1 inch from the Sun. On that scale, Pluto would be about 40 inches away. The entire planetary system, every world and moon and asteroid, would fit comfortably on a large dining table. But the Oort Cloud, on that same scale, would not even begin until you walked several hundred feet from the table. Its outer edge would lie about 1.5 miles away. The planets are a few specks of dust in the middle of a sphere 1 mile wide. And that word, sphere, is the second thing the school diagram gets wrong. When we picture the solar system, we picture a flat disk, like a dinner plate. The planets really do orbit that way, all of them tracing paths on roughly the same flat plane. But the Oort Cloud does not follow that rule. It is not a ring. It is not a belt. It is a shell. It wraps around the Sun from every direction at once, above and below, left and right. A vast hollow sphere of ice, with our entire familiar solar system suspended like a moat at its centre. We are not living on a disk. We are living inside a bubble. That bubble is not uniform. The part nearer to us, called the Hills Cloud, or the inner Oort Cloud, is denser and flatter, shaped more like a thick disk, and it holds something like 5 times the mass of the region beyond it. Farther out, that inner region gives way to the true outer Oort Cloud, the spherical shell that surrounds everything. The objects out there are not rocks like the asteroids between Mars and Jupiter. They are ice, frozen water, frozen methane, frozen ammonia, frozen carbon monoxide. They are the pristine leftovers of the solar system's birth, 4.5 billion years ago, preserved in the absolute cold of deep space, almost completely undisturbed since the planets formed. It is tempting to imagine these icy worlds have always been out there, that they formed at the edge and stayed at the edge, a quiet shell hanging in place since the beginning. The truth is far more violent. Those trillions of frozen bodies were not born in the dark. They formed much closer in, near the giant planets, in the warm and crowded chaos of the young solar system. And then they were thrown out. When the solar system was new, the orbits of Jupiter and Saturn were not the stable, well-behaved paths they are today. The giant planets shifted and migrated, and as they moved, their immense gravity acted like a slingshot, hurling the leftover ice of creation outward in every direction. Some of it was flung so hard it escaped the sun entirely and vanished into interstellar space forever. The rest did not quite reach escape velocity. It sailed out to the farthest edge of the sun's reach and stalled there, in the cold and the dark, where it has waited ever since. The Oort Cloud is not a peaceful nursery. It is a graveyard of construction debris that the giant planets threw away 4 billion years ago. Before we go further, if you are kind enough, a gentle like and tap on subscribe would mean the world to me. It is a small gesture, but I hold it with deep gratitude because every bit of your support keeps this tiny universe alive. Now, the word cloud does a lot of damage to the imagination because it suggests something thick, a blizzard of tumbling ice you would have to steer a spaceship through. The reality is the opposite. The Oort Cloud almost certainly contains trillions of objects, but the volume of space it fills is so staggeringly large that those trillions are spread impossibly thin. The average distance between any 2 objects out there is tens of millions of miles. If you were standing on one of these icy worlds, in the middle of the cloud, you would see nothing around you but stars. You would not see the next object. It would be tens of millions of miles away, far too distant and too dark to make out. You would not even see our sun as a sun. It would be just the brightest star in an otherwise ordinary sky. The Oort Cloud is not a crowded place. It is the loneliest, darkest, emptiest place that still, just barely, belongs to us. Which brings us to the most unsettling fact of all, the one that sits underneath everything I have just told you. We have never seen it. Not the shell, not a single confirmed object within it. With all of our telescopes, all of our space observatories, all of our decades of looking, we have never once photographed a verified body in the Oort Cloud, never tracked a specific lump of ice orbiting out there in that distant dark. Everything we believe about this structure, its size, its shape, its contents, its history, we believe without ever having laid eyes on it. And the reason is simple and a little chilling. The objects out there give off no light of their own. They can only reflect the sun's. But at 50,000 astronomical units, the sun is just a bright star, and the light it throws on these small dark bodies is almost nothing. Trying to spot a lump of ice a few miles across at that distance is like trying to see a piece of coal against a black sky from 1,000 miles away. It is, for now, simply beyond our optical telescopes. You might think infrared could rescue us, since it sees heat rather than reflected light. But these objects are not just dark. They are unspeakably cold, only a few degrees above absolute zero, so cold that they give off almost no heat of their own. Their warmth is indistinguishable from the background chill of deep space. Darkness, cold, and sheer distance all conspire at once to keep the edge of our own solar system completely hidden from us. So here is the question that should be bothering you by now. If we have never seen the Oort Cloud, if no telescope can find it and no camera has ever caught it, then how do we know with such confidence that it is there at all? How can astronomers describe the shape and size and history of a structure that has never once been observed? The answer is that the Oort Cloud has been leaving us messages for as long as there have been people to look up. We just had to learn how to read them. And the messengers, it turns out, are the most beautiful objects in the night sky. For as long as human beings have looked up, comets have unsettled us. A comet is not like anything else in the sky. The stars are fixed and patient. The planets wander, but slowly and predictably. And then, every so often, something new appears, hanging in the dark with a long glowing tail, brightening for weeks and then fading and vanishing, not to be seen again for a lifetime, or 1,000 lifetimes, or ever again. Ancient civilizations read them as omens, warnings of plague or the deaths of kings. We know better now. But the truth turned out to be stranger than any omen. Every great comet that has ever crossed our sky was a messenger, and the message it carried, once we learned how to read it, was a map of a place that no one has ever seen. The reading began with a simple observation. Comets, it turns out, come in two very different families, and the difference between them is the first clue. The first family is the short-period comets. These are the reliable visitors, the ones that return on a schedule. Halley's Comet is the most famous, sweeping past the Sun roughly every 76 years. Comets like this take less than 200 years to complete an orbit, and crucially, they travel on roughly the same flat plane as the planets. They come from a region we can actually see, the Kuiper Belt, a ring of icy debris just beyond Neptune. The second family is the strange one. These are the long-period comets, and they do not play by the same rules at all. Their orbits are enormous, taking thousands or even millions of years to complete a single loop. The comet Hale-Bopp, which lit up our skies in 1997, will not return for roughly 2,500 years. The comet known as Comet West takes something like 250,000 years to come back around. These objects fall toward the Sun from distances so vast that they can only be coming from a reservoir far, far beyond the Kuiper Belt. The question was, where exactly, and in what shape? In 1950, a Dutch astronomer named Jan Oort found the answer hidden in the numbers. He studied the paths of these long-period comets, and he noticed something that should not have been possible if the comfortable assumptions were true. The long-period comets do not arrive on the flat plane of the planets. They do not come politely from the left or the right. They drop straight down from above the North Pole of the Sun. They climb up from beneath the South Pole. They arrive from every angle and every inclination imaginable, scattered unborn across the entire sky, with no preference for any direction at all. That uniformity was the smoking gun. Think about what it means. If these comets were falling out of a flat ring, like the Kuiper Belt or the asteroid belt, they would all arrive on roughly the same plane, like cars merging onto a single highway. The fact that they come at us equally from every direction, from above and below and every side, tells you that the place they come from must surround us equally on every side. The reservoir cannot be a ring, it cannot be a disk, it has to be a sphere. A Dutch astronomer, simply by plotting where comets came from, had deduced the shape of an invisible shell wrapped around the entire solar system. The idea of a distant comet reservoir had first been floated by the Estonian astronomer Ernst Öpik back in 1932, but it was Oort who worked out the modern spherical model from the evidence, and the structure has carried his name ever since. There was a second clue, and it answered a different question. Not what shape the reservoir is, but whether it needs to exist at all. The clue is that comets are fragile, and they are dying. Every time a comet swings close to the Sun, the heat boils away its ice, and that escaping vapour is what forms the glowing tail. The tail is not a flourish, it is the comet bleeding to death. A little more is lost with every pass. After enough trips around the sun, a comet simply runs out of ice and crumbles into dust and rubble. And here is the problem. The solar system is 4.5 billion years old. If all the comets we see had been orbiting since the beginning, they would have burned out and disintegrated long, long ago. There should be none left. The sky should be empty of them. And yet fresh, long-period comets keep arriving. New ones we have never recorded before, falling in from the dark. There is only one way to explain that. Somewhere out there, far beyond the planets, there has to be a vast supply tank. A reservoir holding billions upon billions of comets in deep freeze, untouched, waiting. Most of them simply orbit in the cold and the dark forever, but every so often, something reaches in and nudges one of them, just slightly, just enough to tip it loose and send it falling inward toward the sun, to replace one of the comets that has died. The steady trickle of new comets is not possible unless that hidden tank is real. So we know the reservoir exists, because without it, the comets we see could not exist either. But this raises a question of its own. What is the something that reaches in and nudges those comets loose? And the answer is where this story stops being only about our solar system and starts being about the galaxy. Out at the edge of the Oort Cloud, the sun's gravity is almost spent. On Earth, the sun's grip is overwhelming, an iron hand that holds our planet in a tight and predictable orbit. But 50,000 astronomical units away, that grip has faded to a whisper. It is so weak out there that the sun is no longer the only thing pulling on these icy bodies. The rest of the galaxy can be felt. The combined mass of the Milky Way, the great disk of stars, the dark matter woven through it, the dense core at its heart, exerts its own gravitational pull on the outer edge of our solar system. Astronomers call this the galactic tide. Just as the moon raises tides in the oceans of Earth, the galaxy itself raises tides in the Oort Cloud. It tugs on these distant objects, stretching the cloud, distorting it, and constantly working against the feeble pull of our own sun. And it is this galactic tide, this grip of the whole Milky Way on the rim of our home, that keeps the outer cloud puffed into a sphere, and that periodically shakes comets loose and sends them tumbling toward us. And then, in 2025, this already strange picture got stranger still. For a long time, astronomers had assumed that the denser inner region of the Oort Cloud, the Hills Cloud, was a simple, smooth, thick disk. But in February of 2025, David Nesvorny and his colleagues at the Southwest Research Institute, running detailed simulations on one of NASA's supercomputers, found something nobody had predicted. The inner Oort Cloud is not a smooth disk at all. It is warped, and it holds a structure, a spiral. Two great twisting arms of icy bodies, stretching roughly 15,000 astronomical units from end to end, tilted about 30 degrees from the plane of the planets. From a distance, the inner edge of our solar system would not look like a disk or a shell. It would look like a tiny galaxy. The cause is the galactic tide again. Over billions of years, the steady pull of the Milky Way has slowly twisted the orbits of these inner objects into a spiral that echoes the shape of the very galaxy that sculpted it. The edge of our solar system, it seems, is secretly shaped like the galaxy that contains it. And in a detail that says everything about how little we have actually seen of our own backyard, the astronomer leading the work first noticed the spiral almost by accident while preparing a show for a planetarium. We did not photograph it. We could not. We found a galaxy-shaped structure at the edge of our solar system inside a computer simulation, because the real thing remains completely invisible to us. There is perhaps one faint exception. One object that may be our first true glimpse of the inner edge of all this. In 2003, astronomers led by Mike Brown discovered a small reddish world they named Sedna, far out beyond the Kuiper Belt. Sedna's orbit is bizarre. At its closest, it comes no nearer to the Sun than about 76 astronomical units, well beyond Neptune. and it takes something like 11,000 years to complete a single loop. What makes it strange is that it never comes close enough to Neptune for Neptune's gravity to have placed it there. Something else puts Sedna on that lonely path. Perhaps a passing star, perhaps the gentle hand of the galactic tide. Many astronomers think Sedna is our first detected member of the inner Oort Cloud, a single dim envoy from the great shell beyond. And even Sedna, the closest of these objects, is so distant and so faint that it appears as little more than a slowly crawling point of light. The cloud it may belong to still lies far past it, in the dark, unseen. So consider where that leaves us. We have mapped the size of a structure we have never seen. We have deduced its spherical shape from the directions that comets fall. We have uncovered a hidden spiral inside it, shaped by the gravity of the entire Milky Way. We know its history, its contents, and the forces that hold it together. And we know all of it without ever once having laid eyes on a single object inside it. It is one of the strangest situations in all of science, a place we can describe in detail and have never observed at all. But there is one more thing the comets have been trying to tell us, and it is the most unsettling message of all. The Oort Cloud is not a quiet, static shell hanging safely at the edge of our home. It is a thin and permeable membrane, not a wall. The same galactic tide and the same passing stars that keep it spherical and feed us our comets can also reach in and strike it violently, scattering its frozen worlds like a hand swiped through a swarm of insects. The records hidden in our solar system say that this has happened before, and the maps of the stars around us say that it is going to happen again, that something is already on its way, a visitor that will pass directly through the outer shell of our solar system and send a long rain of comets falling inward toward the planets, toward us. That is where we go next. We like to think of the edge of the solar system as a border, and borders feel safe. They are the place where home ends and the outside begins, a clean line you can stand behind. But the Oort Cloud is not that kind of border. It is not a wall, and it does not keep the galaxy out. It is a thin scattering of ice across an enormous volume, held in the weakest grip the sun has, and the galaxy reaches through it constantly. Stars drift past, and every so often, one of them comes close enough to do real harm. This is not a hypothetical. About 70,000 years ago, recent enough on the cosmic clock that human beings were already walking the Earth, already telling stories around fires, a small, dim star passed through the outer edge of our solar system. We have found it. Astronomers call it Schultz's star, and they have traced its path backward through time. It came within roughly 52,000 astronomical units of the Sun, sailing through the outer reaches of the Oort Cloud, while our ancestors looked up at the same sky. They may even have seen it, a faint red point that brightened for a while and then was gone. It would have meant nothing to them. They could not have known that a star had just brushed against the outer shell of their home. And Schultz's star was not unusual. Encounters like it are not rare. Over the long history of the solar system, stars pass within reach of the Oort Cloud surprisingly often. The best current estimates suggest that a star drifts within a single parsec of the Sun, roughly 200,000 astronomical units, on the order of a dozen times every million years. The shell is brushed and shaken again and again. Most of these passes are gentle, but not all of them are. And there is one coming that will not be gentle at all. We know its name. It is called Gliese 710. It is a dim orange dwarf, a little more than half the mass of our Sun, currently drifting about 62 light-years away in the constellation Serpens. Right now it is far too faint to see without a telescope, an unremarkable speck in a crowded sky. But it is moving toward us, and astronomers, using the extraordinarily precise measurements of the European Space Agency's Gaia mission, have charted its course with real confidence. In roughly 1.33 million years, Gliese 710 will not merely brush the outer edge of the Oort Cloud, it will pass directly through it, coming within something like 10 to 13,000 astronomical units of the Sun. This is not a maybe. With the Gaia data, the certainty is essentially total. It is going to happen. And it is worse than a quick flyby, because Gliese 710 is slow. Most stars that wander through the neighbourhood are moving fast, tearing past at a pace that gives them little time to do damage. Gliese 710 ambles. It will move through the outer Oort Cloud at a relative crawl, which means it will linger there, its gravity working on the frozen comets around it for far longer than a faster star ever could. As it passes, it will become, for a time, the brightest and fastest moving object in the entire night sky, outshining every star and every planet, a brilliant point visibly sliding across the heavens of whoever is alive to watch it. And in its wake, it will leave a disaster in slow motion, because as Gliese 710 ploughs through the outer shell, its gravity will tear loose a vast swarm of comets and fling them inward, toward the Sun, toward the planets. Astronomers who have modelled the encounter estimate it will trigger a cometary shower of roughly 10 new comets every year, and that this shower will not last a season or a century. It will last for 3 to 4 million years. For longer than our entire species has so far existed, the inner solar system will be raked by a steady rain of comets knocked loose from the edge. Most will simply blaze past and vanish, but over a span of time that long, with that many objects falling inward, the odds of one of them striking a planet steadily climb. The odds of one of them striking Earth climb. The Oort Cloud, that distant, invisible shell we have never even seen, is wired directly to the fate of life on our world. A star none of us will ever meet, drifting through a structure none of us will ever visit, can reach across the light years and the ages and rain fire on the only home we have. And we already know what a single impact can do. 66 million years ago, an object only a few miles across struck the Earth and ended the long reign of the dinosaurs, erasing roughly 3/4 of all the species that were alive at the time. One rock. A comet shower lasting 3 or 4 million years does not guarantee a strike like that, but it loads the dice, and then it rolls them, over and over, for longer than the entire human story has so far lasted. Sooner or later, a long enough rain finds a target. And here is the cruel symmetry of it. The same shell that lets the galaxy reach in and strike us is the shell that keeps us from ever getting out. We are trapped on both sides of it. When you call the Oort Cloud a barrier, it is easy to picture the wrong thing, a dense field of ice you would have to weave through and dodge. But we have already seen that the cloud is almost unimaginably empty. The danger of crossing it is not what is there, the danger is what is not there. It is the emptiness itself. Inside the planetary system, long-distance travel has a trick to it that science fiction calls island hopping. You move from world to world, stopping along the way at asteroids and moons to mine ice and refuel, so that you never have to carry everything you need from the very start. It works because the islands are close enough together. You can hop from Earth to Mars, from Mars to the asteroids, from the asteroids to the moons of Jupiter. But once you cross the orbit of Neptune, the islands disappear. The Oort Cloud may hold trillions of objects, but they are scattered so thinly that the average distance between any two of them is about the same as the distance from the Earth to Saturn. You cannot island hop across a desert where the stepping stones are that far apart. There is nowhere to stop, nowhere to refuel. You would be entering a void 100,000 astronomical units wide, with no resupply of any kind. That forces you to carry every ounce of fuel for the entire crossing from the moment you leave. And this collides with one of the most unforgiving facts in all of engineering, the rocket equation. To carry more fuel, you need a bigger ship. A bigger ship needs even more fuel to move it, which needs a bigger ship still. The numbers spiral upward against you, and they make it effectively impossible to build a chemical rocket that could cross the Oort Cloud in any reasonable span of time. With the propulsion we actually have, a crossing would take tens of thousands of years, and a journey of 30,000 years is not a journey. It is a relay across hundreds of generations, a ship in which everyone who remembers the launch is long dead, in which the civilization that built the vessel might itself have risen and fallen and vanished before the ship ever reaches the far side. So the Oort Cloud does something quietly profound and a little terrible. It quarantines us. It seals our entire civilization inside the gravity of a single star more completely than any wall ever could. We can look out at the galaxy. We can map it, photograph it, dream about it. But our physical reach ends at the inner edge of a shell we cannot even see, and the physics of travel does not currently offer us a way through. We are, for the foreseeable future, an island species. Not by choice, by the geometry of space and the stubbornness of the rocket equation. We have not accepted this quietly. We have already sent a piece of ourselves ahead to scout the way, and the story of that scout is the most human part of this entire picture, because it measures the size of the barrier in terms a heartbeat can understand. Voyager 1 is the farthest object human hands have ever made. It launched in 1977, swept past Jupiter and Saturn, and then simply kept going, out past the planets, out through the heliopause it crossed in 2012, into interstellar space. Right now, it is more than 15 billion miles from Earth, about 165 times farther from the Sun than we are, and it is still falling outward at 38,000 miles an hour. In 2026, it reaches a distance of one full light day from home. By every human measure, it is a triumph almost beyond words. And it is dying. Voyager runs on a nuclear battery, a generator that turns the heat of slowly decaying plutonium into electricity, and that heat is fading. The spacecraft loses about 4 watts of power every year, and after nearly 50 years, it now produces less than half the power it launched with. To keep it alive, the engineers at NASA have been switching off its instruments one by one in a careful, predetermined order, like a doctor easing a patient gently towards sleep. 7 of its 10 instruments are already dark, only 2 are still running. The mission's own scientists, asked how much longer it can last, no longer give confident answers. As one of them put it, every day could be the last. Sometime in the next several years, perhaps in the 2030s, the final instrument will fall silent, and Voyager will stop speaking to us. It will not stop moving. It will keep coasting outward at 38,000 miles an hour, exactly as it does now, a dead and frozen machine. But here is the part that should stay with you. Even at that speed, Voyager will not reach the inner edge of the Oort Cloud for about 300 years. It will not pass through to the far side for nearly 30,000. Long before it ever touches the true edge of the solar system, it will be a silent fossil, a piece of 20th century metal drifting through the dark. It will pass in among the trillions of frozen comets and become, in effect, just one more object in the shell. A tiny artifact of a species, sealed inside the same cage as the species that built it, carrying a golden record of our music and our voices toward an audience of ice that will never listen. So what is the Oort Cloud in the end? It is 2 things at once, and they cannot be pulled apart. It is a cradle. It is the true and complete territory of our star, the largest structure we will ever genuinely own. It holds the pristine, untouched material of our own creation, frozen and preserved for 4.5 billion years, a perfect record of how our solar system was born, waiting in the dark for us to become capable enough to go and read it. In that sense, it is an inheritance, the outer wall of the only home we have. And it is a cage. The very scale that makes it magnificent makes it a prison. It imposes a distance and a difficulty that our bodies and our machines cannot yet overcome. It is the universe quietly informing us that, for all our ambition, for all our dreams of reaching other stars, we are not ready, and may not be ready for a very long time. We are residents of this solar system first, and citizens of the galaxy only in our imaginations. And it raises a question humanity has been asking for a long time. In a galaxy of 400 billion stars, billions of them far older than our Sun, why have we never heard from anyone? There are many possible answers, but perhaps one of them has been hanging quietly at the edge of every solar system all along. Perhaps every civilization that has ever arisen has found itself sealed inside its own shell of ice, close enough to dream of the stars and far too small to reach them. Perhaps the silence we hear when we listen to the galaxy is not the silence of an empty universe. Perhaps it is the silence of countless islands, each one walled off behind its own invisible barrier, each one calling out into the dark and hearing nothing come back. We do not know if we will ever cross it. We do not know if any species, anywhere, ever has. We do not know whether the shell around us is a wall we will one day learn to pass through, or the permanent edge of everything we will ever be able to touch. What we do know is that it is there, vast and silent and invisible, and that the comet that lights up your sky and the star that will one day rain fire on your distant descendants both come from the same place. The dark shoreline at the edge of our world. Right now, as you hear this, that shoreline is doing exactly what it has always done. Trillions of frozen worlds are drifting in the cold, so far apart that each one sees nothing but stars. The hidden spiral is turning, slowly, unseen, shaped by the pull of a galaxy that does not know we are here. Somewhere in the constellation Serpens, a dim orange star is falling toward us, patient and certain, 1,000,000 years away from an appointment it will keep. And a small, dying spacecraft is coasting outward through the dark, carrying our voices toward a wall it will never feel, on a journey that will outlast every person who has ever known its name. We have mapped the edge of our home. We have never seen it, and we have not yet found the door.